This video is about physical and chemical properties and changes. Physical properties are characteristics of an object or substance that can be observed or measured without changing what it is. So if you think about it, it's how we describe matter or an object. Physical properties include shape, color, shine, odor, taste, boiling point, melting point, freezing point, density, volume, texture, conductivity, malleability, which would be the ability to change shape. So all of those are descriptive things. When you look at an object, these words can come to mind when you're describing it. So the ratio of atoms has not changed. No new substance has been formed. Chemical properties, a characteristic of a substance or material that focuses on how the substance reacts with others chemically. So it's the ability to change into something new. Examples would be flammability, rusting, corroding, combustion, reaction to other substances, neutralization, that deals with the base and acids, and so forth. So physical properties versus chemical properties. So on physical properties, it can be observed or measured without changing it. They're descriptions and descriptive words. Your senses can observe it, and it's facts about a substance. Versus chemical properties, those can be observed or measured during a chemical reaction. It's the ability to change. These cause something new to form with new and different properties. It's the reason why one or more substances changes into new substances. Now we're going to talk about physical and chemical changes, so different from properties. First, let's think, how can something change? Focusing on this specifically, things can change chemically and they can change physically. With a physical change, it's a change made to the original physical properties. So thinking about those verbs that we looked at before, it affects a physical characteristic without affecting or changing what the substance is. So if you chop up a stool or paint it, the substance is still wood. You can hypothetically put it back together and make it how it was before. It hasn't changed into something new. Whereas a chemical change, that is a result of a chemical reaction. So something happening to the substance that changes what it is. A new substance is made if there's a chemical change. It results in new and unique chemical and physical properties because, again, it's something different now. If you burn the stool, it's going to become ashes. That's a new substance. You can't make the ashes back into the stool. Now we'll talk about chemical change indicators. So when a new substance is made, you're normally going to be able to observe one or more chemical change indicators. So first one, bubbling, without adding heat, so not boiling. It's bubbling because of a reaction. 2, formation of a precipitate. That's a solid that forms as a result of mixing, say, 2 liquid chemicals. Okay. Color change. Not from dilution, so it's not adding food coloring because you're just watering down the food coloring if you do that. It's like pH strips or indicator solution, that kind of thing. Rapid release of energy in the form of heat, light, and or sound. Change in heat or temperature, but that's not due to applying heat directly. So it's a result of these things mixing together, a reaction happening. Lastly, a new substance is made. That's the best indicator there is. So if a chemical change occurs, you can't make it back into the substance it was beforehand. So all of these are not indicators of a chemical change. If you put rubbing alcohol on your skin and it evaporates, cooling your skin, that is not a chemical change. Same as breaking a pencil. That's not a chemical change indicator. Ice cream melting. That's a state change. It was frozen, but it's still ice cream, even if it's liquid. Salt dissolving in water. That's a dilution. That's not a chemical change. And cutting up paper or anything like that, that is not a chemical change. Those are all physical changes. These are indicators of a chemical change, or these are some examples. So a pH indicator solution changes color when vinegar was added to it, changes to red. If you put zinc into a solution of hydrochloric acid, bubbles will form. Putting an Alka-Seltzer in water creates CO2 bubbles. There's another bubbling example. And then when you add or test your pH for your pool, when the test strip changes color, that is another indicator.